Hey everybody, today's lesson is about solving quadratic equations by factoring. So our goal is to solve quadratic equations by factoring. So we need our equation to be in standard form. That means ax squared plus bx plus c equals 0. That equals 0 is very important. It has to equal 0 in order for us to be able to solve using this method. And then we have the zero product property, which says if a times b equals 0, then A equals 0 or B equals 0. And sometimes we call this the ZPP. And this is just the main idea that's going to get us through solving by factoring. So the first step is to factor. So if I'm factoring this trinomial here, I'm splitting x squared into x and x. Then my only choice for 2 is 2 and 1. And since it has to add to -1, it has to be -2 and +1. So I factored it, but it equals 0. So basically, this would be a times b, right? I've got a times b. And that means a equals 0 or b equals 0. So I'm going to set them equal to 0. X minus 2 equals 0, and x plus 1 equals 0. And now I have two very simple equations to solve. This would mean x equals 2. And x equals -1. And these are what we call our zeros or solutions. And that's it. I factor and then I solve. And we're done. So number 2, I need to split my 1x squared into x and x. And then 36. We've got a lot of choices. I've got, 12 times 3, 6 times 6. 9 times 4, and so on. There's even more than that. But I need those outside and inside terms to add to 13. So remember, as we get really good at factoring, we're going to start making really good guesses. So I'm going to start with 9 and 4. And I'm going to add them both because I have a 9x and a 4x. And those add to positive 13 if they are both positive. So that means x plus 9 equals 0, and x plus 4 equals 0. So x equals -9, and x equals -4. So something we can talk about with this problem is that we have two different pieces here. First, we break up our original trinomial into its factors, which were x plus 9, and x plus 4. Then we solved it to find these solutions, which were -9 and -4. So you can see how those relate. It's very important to be able to distinguish between what we're doing and what these terms mean and what we're looking at. It'll just make you a better mathematician. So let's move on to number 3. So remember when I said that it had to be in standard form? That means you have to have it equal to 0 to solve. So I'm going to add 2 to both sides. And you're going to remember that it must equal 0 to solve by factoring. So once it equals 0, again, I'm going to check for a GCF first. I don't see one. So I'm going to factor into two binomials. And I'm going to split my 2x squared into 2x and x. And then I have a 2. It's either going to be 2 times 1 or 1 times 2. But when I check here, I've got a 2x and a 2x. And that's going to add to 4 or 0, which is not 5. So that's not the right combination. So let's try 1 and 2. So I've got a 1x and a 4x. And I can definitely get those to be a -5 if they're both negative. So I'm going to make them both negative. And remember, your last term is positive here. So as long as it's a negative times a negative, we're good with that positive. So I set them equal to 0, each factor. So 2x minus 1 equals 0, and x minus 2 equals 0. So x equals 1/2, and x equals 2. Okay. Number 4. Remember, the very first step in any factoring problem is to look for the greatest common factor. So what's the GCF for number 4? Well, it is -4. If your first term is negative, if a is negative, pull that out. We don't want it there. So I've got x squared minus 3x minus 10 equals 0. And remember, we have to check to make sure whether or not we can still factor. And I have a trinomial, so I can. A 1x squared here, so x times x. So I need two numbers that multiply to 10 and add to -3. So I'm going to try 5 and 2. And I know that it's -5x because I've got a -5x plus 2x to add to that middle term, which is -3. So once I'm done, I need to set my factors to 0. So remember, 4, that -4 is just hanging out. It doesn't have a variable or anything, so I don't have to worry about that. I'm worried about x minus 5 and x plus 2. So x minus 5 equals 0, and x plus 2 equals 0. So my solutions are x equals 5 and x equals -2. So I hope you're following along, writing everything down, pausing when you need to. Make sure you always pause and rewind anytime it's necessary. So number 5, remember we have to have it equal to 0. So I'm going to subtract x from both sides. So I have 9x squared minus x equals 0. And remember, you're looking for the greatest common factor. So I'm going to take out an x. So I have 9x minus 1 equals 0. So now, in this case, I do have an x out front. So my factors are x. I'll write that down over here. Factors are x and 9x minus 1. And then we have to find our solutions, or sometimes we call them zeros, by setting x equals to 0 and 9x minus 1 equal to 0. But just note that this is slightly different from number 4, because I didn't have a variable all the way out front. When I do have a variable out front, I can't forget about setting it equal to 0. So x equals 0 and x equals 1 over 9 are my solutions. So 0 and 1 over 9 are the solutions to that quadratic equation. So what you're going to do is you're going to try number 6. And if you would, for Mrs. Sullivan here, explain the similarities and differences between just factoring and solving by factoring. It's important to note the difference. So try number 6, answer that question on the back, and come ready to ask some questions.